So, today we are going to be talking about the time value of money, but this time the present value. So, let's say that you want to have a certain amount of money saved after a certain amount of time, investing it at a certain average rate. Let's say you have a specific amount of money you want. Maybe you want to retire with $3 million in 30 years from now. How much would you have to put away now in order to make that happen? And do you have that money now that you could put away and just leave it be in order to make that happen? So let's talk about that. Now, some people will point out here that it's a lot more realistic to say, well, how much per paycheck or how much per month would I have to set aside, as opposed to assuming that the person's going to have it all right now today. And that is true, but we will be talking about how to do that calculation in the annuity section. In this case, we're going to assume that how much lump sum would we need today in order to have a certain amount of money in a certain number of years from now, given a certain investment. So let's start with this first one. It asks how much should be invested now at a 5% annual capitalized quarterly interest rate to have $100,000 in 10 years. So automatically we know that it's going to be less than $100,000, right? Because we know that money grows over time with these positive interest rates. And so therefore we know that the answer should for sure be less than $100,000, because then over the course of the next 10 years it's going to grow to be $100,000. So let's first write down what we know. We know that the present value is what we're trying to figure out, right? How much must be invested now in the present day in order to get what we need. The future value is $100,000. We would like for in 10 years from now to have $100,000. The interest rate is 5%. And the number of compounding periods. Well, the thing is, this is capitalized quarterly. And so for the annual interest rate, we need to actually divide it by 4 because there's 4 quarters in a year. A quarter happens every 3 months or 4 times a year. And so in this case, the number of compounding periods overall is going to be equal to 4 times 10, because we want to know how much there is in 10 years. And so over the course of 10 years, there are going to be 40 compounding periods, since 4 will occur every year. Okay, now I'm going to put this into this equation. So present value is equal to $100,000 over 1 plus, well, actually, I didn't calculate what this was. I believe it's 0.00125, but let's just double check that. Yeah, divide by 4. Yeah, 0.0125. I added an extra 0 there. One more 0 than we actually needed. There we go. So 1 plus 0.0125, and that's the power of n, which is 40 compounding periods. So then we're going to figure out the denominator. And the denominator is going to be about 1.6436 approximately. So $100,000 divided by 1.6436 is equal to about $60,842.05. So therefore, this tells us that if we invested $60,842.05 a day at this interest rate, we would end up with $100,000 in 10 years. So we would gain about, a little less than $40,000 by doing that. So you know what? If you have that money right now and you'd like to do that, fantastic. That's great. Okay. Let's move on to this next one. Let's say that Jennifer wants to have $3,500,000 saved for retirement, which she will start 40 years from now. How much does she need to invest now at an 8% annual capitalized monthly return in order to make that happen? Okay, so first let's write down what we know. So we don't know the present value. We want to know the present value. We need to know how much of her money would she need to set aside right now and have this and do this process with, in order to, in 40 years from now, have 3.5 million for retirement, which pretty decent retirement. Okay, future value would be 3.5 million. Ooh, let's draw that a bit better. Okay, the interest rate is going to be 8%. Now it is capitalized monthly, so therefore I'm going to divide the annual interest rate by 12 and get that it is 0.006 repeating. And then n is the number of compounding periods. Well, the thing is, it's compounded or capitalized monthly, and it's for 40 years. So that would be 40 years times 12 compounding periods in 1 year per year. So 40 times 12 gives me 480. Okay, so now if we go back up to the equation was present value equals future value over 1 plus I to the power n. So present value is equal to 3.5 million over 1 plus 0.06 repeating, or sorry, 006 repeating rather, to the power of 480. So let's figure out what that's going to be. 1 point the power of 480. Okay, so that is going to be 24.273378 approximately. So 3.5 million divided by 24.273378. That is equal to $144,190.89. So that's pretty cool. That means that if you invest $144,190.89 today at an 8% rate, annual rate, compounded monthly for the next 40 years, you'll have $3.5 million. That's pretty cool. Now, I recognize most people do not have this amount of money sitting around because even $144,000 is quite a lot of money. However, compared to 3.5 million, right? That is even more life-changing, right? That is enough money to retire with, right? That is incredible. So yes, both of them are a lot of money, but the 3.5 million is quite a different number than 144,000 and something. So that's pretty incredible if you ask me. All right, well that's it for this one. We'll see you for the next one.